Next thing is this guy. All right, perfect. Hello? Are you there?
Yeah.
Hey, can you hear me? Okay, you can hear me. That's good.
Yeah.
All right, so yeah, I just stepped out for a bit. I know it's not time yet. Anyways, did you get my email by chance?
Yeah. I printed out the sheets.
Okay, perfect. Yeah, like so I was talking to your teacher, Susan, and then yeah, she mentioned she actually sent all those worksheets to do.
Yeah.
So like I think it would be great if we spent and like maybe today, Monday. When's your test again?
It's Friday.
Right. Okay. Yeah. Do you mind spending more time on this coming week? Maybe like Monday, Tuesday, Wednesday.
No, that should be fine.
Okay. Yeah, because in terms of all the worksheets, it's not bad, but I wanted to go over them maybe like step by step.
Yeah.
How are you with the graphing so far? I know we didn't talk about it yet, but only briefly. But I know you guys been doing it. How are you doing in it?
I think I pretty much have it down. Like
Oh,
graphing.
good. Okay. What is that? Oh no. Can you hear me? What happened?
Like, okay. Do you have the thing where it's like practice for quiz E?
Yeah, I have them all in here. Let me see. Quiz.
So if it's like
This guy?
tangent, if it's like number 3.
Yeah. Okay. This guy?
Yeah, that one's kind of weird to me.
All right. So like tangents and cotangents, they're kind of similar.
Yeah.
But like just I guess like, taking a look at what a tangent graph looks like.
Yeah.
This is how I usually do it. You have to have in your do you guys have a cheat sheet or do you have to memorize how the graph looks?
No, you have to memorize.
Okay. So yeah, you have to like I guess for what I'm talking about is here, that's why I had that in the beginning. Like if you look over here.
Yeah.
So this is the typical tangent graph.
Yeah,
I would probably like if you don't have them memorized, just draw them in like 5 times, and by then like you'll have muscle memory to know like what they are. The only important parts for all these guys are like how they look like, and then where there's 0. You know, because like that's all you do, and then where the asymptotes are. So if you take a look at this, and then let's go back to so the asymptotes here is pi 2, and then 3 pi over 2, and then you have zeros at 0, pi, and 2 pi. So and then you look at the shift. I would definitely do these one by one. So when you're looking at like, your first thing I would do is do the tangent one first, and then the next thing is do the frequency, which is this guy, and then like kind of graph it like one by one, so that you're not doing all things at the same time.
Mm-hmm.
So and the next thing you would graph would be this guy. Plus one would be the phase shift, the horizontal shift.
Mm-hmm.
So this one, you would move this to the left, right, by negative
Oh,
one.
no, that one's actually a vertical shift because it's not.
Oh wait, hold up. Yeah. Good catch. so so pi over 2 over x plus 1. So this is going up. This is a vertical shift plus 1. So going up, and then this one, do you know how to do the frequency?
I mean,
okay.
Yeah, it's just okay, so oh yeah, I know how to do that. But the thing is, like, for tangent, it's just like when you move it to the side, like when it's like horizontal shifts, I'm kind of confused because of the asymptotes.
The horizontal or the vertical?
The horizontals.
Okay. So maybe if we're doing because this is a vertical one, let's just do a horizontal one. So if we did something like, okay, let's take a look at something different. So what if we did like tan x, right? And then plus 1, right?
Yeah.
What if it's that guy? So since this is a plus, you have to move it horizontally by -1, right?
Yeah.
And what that means is you look at the zeros and then the asymptotes. So originally, you just move where those zeros, where there's zeros and asymptotes by 1 to the left. So originally you had this guy, right? You have 0 here. You have this guy. Usually I draw these guys out, then I'll do another one where like I shift it so that I don't get confused by like where they are. So this is the original one, 3 pi. And then so the original asymptotes are right here. Right? And then the zeros are this guy. So that's the original one, right?
Yeah.
And then so what we want to do now is worry about this. So all you have to do is shift this guy by, this is -1. And then also shift this guy by -1. For the most part, when you have this x, it's usually, and then this guy, you have to move it by -1, right? And this guy by -1, and this guy by -1. I would probably just calculate those values and put them on your x-axis. Like this would be -1, whatever pi, -1 plus pi over 2, whatever that number is. That'll be your asymptote. So you have this asymptote right there. And then this, -1 plus pi, you have a 0 there. And then you have this asymptote again by like 3 pi over 2 -1. And then you have this like -1 plus 2 pi. You have another 0 there. So you just shift it, and then you just do this, whatever that value is. Because like it depends on
Oh wait, so you're just gonna write it out?
Yeah, you're just gonna write it out, and then but if you have a grid, it would be better.
Yeah.
If you had a grid, it would be better. But it depends on how you're enumerating them. You know what I mean? Let me give you one that's actually easier. So like, the problem in problem 3?
Yeah.
You know how like the frequency has a pi in it?
Yeah. So it'll just turn like numbers
to numbers, yeah. Because usually when you have this like horizontal shift, it usually has a frequency. It usually has a frequency that will take out all the pi's, which will be really easy for your enumeration.
Yeah.
Yeah. So like, for example, maybe like you had like pi over 2 here, x, and then like plus 1. That one right there would be, so again, just draw it out. Again, I'm just drawing out the regular one. Pi, 3 pi over 2, and then 2 pi. So 0, 0, 0. And this guy and this guy. So, and then this one. And then so this pi, this guy right here, you just times this by like all the x values, right? You just times them. And then this guy, right?
Mm-hmm.
So it's like, so this one would be 1, this one would be 2, and this one would be 3, and this one would be 4. And then so that's just the applying the frequency. Applying the frequency would be this graph.
Oh, okay. So basically,
Right?
just kind of be the same.
It'll be the same, but then the x changes, the x values change. And then the next thing would be +1. It makes it easy. The horizontal shift is easier to calculate now, enumerate, right?
Mm-hmm.
So you're moving to the left by 1. So -1 for all the x's. So -1, -1, -1, -1, -1. So you see how like when you draw it like this, you don't get confused by like doing it all at once.
Yeah.
So if you do -1 here, and I'll probably just like just put all the values 1, 2, 3, 4 instead of like calculating and just do it later. 5, 6, 7. Let's see. So there was a 0 at -1 now. 2 minus, and then there's an asymptote at 0. There's an asymptote at 0. There's a 0 now at 1. There's an asymptote at 2. And there's a 0 at 3. Right? And it's just like this. And whatever, you can technically extend this. And that's how you do it for the horizontal shift.
Oh, okay.
What about the vertical one?
So it moves the asymptotes?
It moves the asymptotes. It also moves anything that's already in the x.
Yeah.
Anything that's already in the x gets like mapped or moved to the left.
Okay, that's why I was confused. Okay. The verticals I know how to do them.
You just for those ones you just move for all these guys, right? They're all in the x equals 0 or y equals 0.
Mm-hmm.
So
that's like the only thing I was confused about.
Okay. What about the other ones?
Okay.
Do you know how to graph the secants and cosecants?
Yeah.
Okay. And then how do you do that one? Like just like generally, how do you do it?
Okay, so the way that like my teacher taught it is so for like, let's say we have cosine and we're doing like cosecant.
Okay.
I mean secant. You know what I mean?
Yeah.
Like the normal cosine, it starts at 1 and then it goes to like for like the numbers it goes like 1, 0, -1, 0, right? So like you kind of like start at the like for the graphs you start at like the 1 and then you for like opens up positive at the beginning and then like for -1 it'll open negative. Okay. Yeah, and that's
that's a good rule. The usual thing I do is in graphing these cosecants and secant counterparts, you just technically have to know what their main guys are, right? The signs.
Yeah. That's what like I was.
Because they're pretty much just in the you dash them out, and then the asymptotes are where there's zeros, right? The original graph.
Yeah.
And then for each one of these, they should share the same maximum minimum y's. And that's it. How you that's easy concept. But once you transform it, like what if you had like a cosecant and secant transform? You usually transform the sines and cosines and draw those transform sines and cosines, and then just do the asymptotes and maximum min. Does that make? Yeah, you probably know. Like, do you know how to do that?
Yeah, I think so. We did it in class like on Friday.
Okay, that's good.
Understood from that.
Okay. Did you do any more practice besides that one?
I did all the homework.
Okay, that's good.
And like I redid the worksheet, the notes, I guess. I redid that, but like without seeing what it looked like, so I just like did them.
Okay.
Are
these? Is the packet like how big is that packet? Is that the one I have is like these guys.
1, 2, 3, 4, 5, 6, 9 pages.
Okay. And then, so...
Yeah, we can try going through maybe some of the questions for practice for quiz E, so I know if
I think that'll be good, yeah. Yeah, because, you know, even if you've seen them or you've done them already, I think it'll be good just to, like, for speed. Speed and accuracy are always the ones. Okay, let's take a look at... Okay, let's probably just do one. Do you have, like, I think it'll be good if you do it the same time as I do it.
Yeah.
Okay, so for one, I think for today, I wanted to cover this and then this, if we can. Just these two. And then we'll do the rest, like, on Monday, Tuesday. Okay, so for number one, so the very first thing I usually do is, like I said, you know, you want to know the graph of, like, the actual untransformed version of it, and then just move and then apply each of the transformation to that to the like separately. So when you do like the frequency one, and then the next one would be doing the horizontal shift. So that's like, and then when you have this frequency one and then the horizontal shift, you also have to apply this the frequency to the horizontal shift, right? So that there's this guy. And then this and then the last transformation would be the vertical shift. Minus pi and then minus 1. So the very first thing would be, okay, so graph this guy out first would be, you know, I'll just do this, so it'll be 1, then negative 1. And for pi, let's see, pi over 2, pi, 3 pi over 2, and then 2 pi. And then so you just go like this, where it's 0 would be here for sine, and then like that, like that, like that, and then like that. And then you just connect these, right? And then so that's the original one. And then so the next one would be to apply the frequency. So applying the frequency is like I said, you just times the reciprocal of these to like 2 times this. Yeah?
It would just be 4, right?
Which one?
It would, the period would just be 4.
For this one?
Yeah. Or that, yeah, we did like, if it...
Oh, yeah. Yes, yeah. Like the period, the period would be 4 in the end, yeah. But like, yeah, because when you times it by the 2 pi, it would be 4. So 1, then negative 1. And what's nice about these, when you have this, you know, frequency that has pi in it, it just really removes it, makes life easy. So 1, 2, 3, 4. 1, 2, and then this, and that. And then now, the next thing, so you took care of that, you took care of this. The next transformation is the horizontal shift. So this one, what is this? This is, so this is always negative. So this is a shift to the right by pi, but you have to apply the frequency to it, right? So it's moving to the right by pi, but then you apply the reciprocal, which is 2 over pi, which is 2. You guys did that one, right?
Yeah.
Okay. Yeah, that's like not, it's just something you have to know. Like if it's inside the parentheses and then you have a frequency here, you always apply it to the horizontal shift. So 1, negative 1. So everything gets moved by 2 in the x-axis. So let's just see, 0, 1, let's make this longer. 2, 3, 4, 5, 6.
Yeah.
So the 0 now becomes 2. And then the 1 becomes 3. And you know, you just do your usual S shape.
And then you have to like minus that.
Yep. Yeah. And then this last one, you move it down.
Yeah.
By negative 1. So instead of 0 now, like where these guys are, it will be at negative 1. So I mean, you just move it down technically. 1, 2, 3, 5, 6. And then so it's this, 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 I guess -2, this, and then this. There you go. And then you could technically finish this off, but just know where your your intervals are. You could always specify where your intervals are.
Yeah.
That's it. So that's what it is. That's the ending. And then, okay. Did you get the same thing?
Yes.
Okay, perfect. All right. What about 2? Let's look at number 2.
Okay.
So this one isn't that bad. It's a secant. So I would just draw the transformations of your cosine, or your cosine, and transform that. So let's see. So this one, okay. So I would probably draw this one at first, and transform it by the amplitude. And the next thing is transform it by. So there's no frequency. It's just a horizontal shift. And this one would be the vertical shift, the +2. All right, let's actually make this bigger. Okay, so the first thing is just draw your regular secant graph. So let's see, that's 0, and you have 1, -1, pi/2, pi, 3 pi/2, and then 2 pi. So I'm gonna draw out the cosine graph first. Just for like over time, you probably don't need to do this, but it's just for context. Okay, there you go. So you have zeros here, or like these are your maximum values, which will be the same for both. And then, but when your cosine is 0, you're gonna have this asymptote. So you should draw those out. And then so since you share the same like min and max or y values, I would fill those out, and then this is what it is. So you have that guy, you have that guy, and then you have this guy. So that in the red is what the secant graph looks like, the original one. And then so now you apply the amplitude, which is like multiplying the y's by just this value, the -1. So when you multiply it by -1, you just pretty much reflect the graph, right, along the x-axis. So pi/2, pi, 3 pi, and then 2 pi. 1 - 1. So with this, I would probably just you don't actually have to draw the whole thing back again, but just put in what this is. Try your best to get the context of the asymptotes. So you have that guy, and right here. There you go. And so the next one is you need to apply your horizontal shift. So here it's positive, so you minus pi/4 from all the x's. So let's see. So this is going to be minus pi/4, minus pi/4, minus pi/4, minus pi/4, and then minus pi/4. A lot of times, like when you're doing this, it's good to create a table, but I think with this, we'll just work with it. So since you have this 0 minus pi over, I'll just start with minus pi over 4, 0. And then I'll make everything increments of pi over 4. And then this is like 2 pi over 4, 3 pi over 4, 4 pi over 4. 5 pi over 4, 6 pi over 4, 7 pi over 4. I think that should be good. 8 pi over 4 minus pi over 4. Yeah, okay. So the first point, oh yeah, this guy's first, 1, negative 1, would be here. Let me just move that away. So that's negative 1. Would be here. Asymptote's at 0. And then it's pi over 2, so that moves. So here would be your asymptote pi over 4. And then since that was pi, you move to the left. So it's right here at 3 pi over 4. And then, let's see, 6 pi over 4 minus pi over 4. That 3 pi over 2 asymptote becomes 5 pi over 4. And then this last part, from 8 pi over 4, it goes to 7 pi over 4 at negative 1. And the asymptote is still that one, so that should be good. There you go. And then the last part is adding the vertical shift. So this is plus, so this just adds 2 to the y's going up. So instead of 1, it'll be, well, yeah, it'll be 3. So let me see, negative 1, that would be 1. So 1, 2, 3. 2 minus 1, yeah, 1, 1 plus 2, that's 3, yeah, that's good. So just shift it. You can fill in the x-axis, but it should be, this guy should go right here. And then somewhere right here. And then let's see, 6, 7, 7 pi over 4. So that's going to be at 1. And that's it. That's essentially, that's what the graph looks like.
Okay, yeah, I understand. Okay.
Okay.
Oh my gosh, I'm so sorry, my dog.
Okay. All right, let's move on to 3.
Okay.
3, actually, we already did that.
Yeah.
Do you still want to see that, or did you want to do number 4?
We can just do number 4.
Okay. Okay, so 4 isn't that bad. When you're doing like cosecants and secants, those are really, yeah, you definitely need to do the counterparts and then just draw out the actual graph from those. But for tan and cotangent, I mean, it is technically the opposite, but you don't really need to draw the tangent to draw the cotangent because it's just the opposite. So okay.
Okay,
so
like, I have a question. So
okay.
when it's like in the parentheses and it's like, it's just for like the period or whatever. So this would
For
be
this
like
one, for this guy, right, in general.
yeah. So it'd be like the period would be 4 pi, right? So you would just draw it like 4 times.
The period would be 4 pi. So you're talking about this guy. So if it's 1/2, you just times it by 2, yeah.
Yeah. So the period would just be 4 pi, which means that you'd like draw it 4 times, right?
This guy, yeah. You draw out this 4 times, yeah.
Yeah. Okay. I was just making sure.
Yep. It's yeah, you could take those shortcuts, but for how long is the exam again? It's How many problems do you guys have, and how long is it?
I think I'm not sure, but for the test, I know there's gonna be a lot of graphing.
Okay, there's actually, I feel like, yeah, it would be a lot of, is it just the graphing, or are there going to be a lot of like more true or false conceptual questions?
I feel like it's probably gonna be half and half.
Okay, yeah, because that's why I wanted to look over the next one, like after this, because
Yeah.
do you remember those questions on y-intercept, and then like
Yeah.
evaluating it and like the secant, yeah, something like that.
Mm-hmm.
Those ones, how do you feel about those ones?
They're okay. They're kind of like iffy. So I would like to go over them to make sure I got them right, but I did it without
Okay.
like the things, so that's why like I'm not entirely sure.
Okay, we'll go over that after these two. We're almost done with this one. Okay. So let's see. 1/2. Okay, so the very first thing I would do here is like, I always start out with the amplitude. So you're going from like amplitude, frequency, horizontal, vertical. And then so this one, you know, cotangent 1/2 x. 1/2 x. All right, let's see what the cotangent looks like. So cotangent, so where is cotangent 0? It's just gonna be where sine is, where cosine is 0. So that's gonna be pi over 2. And then I guess pi, 3 pi over 2, 2 pi, okay. So you have this guy, you have that guy, asymptote at this, asymptote at, whoops, I made a mistake there. So it should be 3 pi and asymptote at 2 pi. So that's the regular cotangent. So the next one, applying the amplitude. So since this is 2, just times this guy by 2. So the amplitude for cotangent would be like how big this guy is, right? So let's see. And then you 3 pi over 2. Oh, I see, okay. And the last thing would be applying this guy. So just times you just times your x by 2 if it's a frequency. So instead of like from 0 to pi, it'll be from 0 to 2 pi. Since you're right, it'll be from 0 to 2 pi. And then the other one, when you could draw like up to 4 pi,
Mm-hmm.
So you could say 4 pi, and then this is like 3 pi. So your asymptote's at 2 pi, and then at 4 pi.
Wait. Okay, wait. So even if it's on the outside, it would like just it would change the asymptotes?
So since this is like a 1/2, like this guy right here,
Yeah.
like you're timesing like a frequency, you always times the x's or your x values by its reciprocal, which is 2. So in the, you had this as this guy, right? Pi 2 over 2.
Mm-hmm.
And your asymptote's at pi, and then at 2 pi.
Yeah.
Your zeros at pi over 2 and 3 pi over 2, and your asymptote's at pi and 2 pi. You times those values by 2. So now it's pi and 3 pi are your zeros, and then your asymptotes, you times them by 2, everything by 2.
Mm-hmm.
Your asymptotes are 2 pi and 4 pi.
Mm-hmm.
Does that make sense? The cotangent one and tangent ones, they're it just stretches when you have like a frequency. This guy right here,
Mm-hmm.
you just times it by all the x's by its reciprocal.
Yeah.
This amplitude, the amplitude here is a little different though than your cosine and sine.
Mm-hmm. Okay. Okay, now I get it. Okay.
You get it? Okay.
Yeah.
Okay, let's move on to the last one then. So
Right.
the last one is cosecant. So these cosecant ones are not that bad. Again, you have to draw your counterpart, which is sine. And so with this, so first thing I would do is draw out the cosecant. The next thing is draw out the amplitude, -1 cosecant x. Next thing is the frequency, -1 cosecant 2 times x, that's the frequency, and then the horizontal shift. 1 minus 1 cosecant 2x minus pi. Okay, so first thing, draw out the original. So that's going to be, where is it? Let's see, 1, -1, pi over 2, pi, 3 pi over 2, 2 pi. So your sine in this case would be, so this is cosecant. So your sine would be here, 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 here. So that's your sine. And your cosecant is 0 here. And has the asymptote where your sine is 0. And then they share the same minimum maximum y's. And then you just draw out, the opposite of them, which is like this guy. So the next one is, it's negative. Negative cosecant is just the opposite. So just flip it over the x-axis. So 1, -1. And then let's say pi, 2 pi, like that, like that. So like that, and like that. Next thing would be.
Okay. Okay, never mind. It was just lagging. I was like, I can't see anything. Okay.
Okay. So this one isn't bad though, right? Like the cosecant one. Okay. So when you do the frequency one, since this is 2, you always times the x's by the reciprocal. So in this case, x times 1/2, since it's 2. So let's see what what happens there. So pi over 2, 3 pi over 2, times all of this by 1/2. Like, it doesn't really, sometimes it messes with you if you don't draw a table, but over time, I just create shortcuts by doing this. So pi over 2 times 1/2, that's going to be pi over 4. Pi times 1/2 is going to be pi over 2. And then 3 pi over 2, oh, I hate this one. 3 pi over 2 times 1/2 is 3 pi over 4. 2 pi times 1/2, that's just pi. That's just pi. So you just fill it in, like, you know, wherever it was you had your asymptotes, which is here. And then here. You probably have 4 of these. If you're going to do it all the way to 2 pi, you just have to, you know, extend it. So, you know, just reflect this all the way here. So the next one would be at the horizontal shift. So this is going to be the, since it's negative, it's going to be plus pi to the right. So again, you just, you know, you just add pi to the x coordinates. And, you know, if you had your calculator, just do the math here. So that's going to be shifting it by pi. So I'll just, you know, I'll draw it out right here. Pi over 4 plus pi over 2 plus pi. Three pi over 4 plus pi. Obviously, pi plus pi is just 2 pi. And yeah, just follow through with the way where the asymptotes are. Similar pattern. Okay. So, you know, obviously clean it up, but that's the gist of it.
Alright, my teacher also taught me, like, the method that she's using is
Okay.
that, like, for example, it's 2x minus pi. What she does is she takes out the 2.
Okay.
And it's just, like, x minus, and it'd be x, like, minus pi over 2, you know?
You could do that, yeah. You could do that, yeah.
Yeah, so, like, if I use that way, it would still...
If it's fast, is it fast? Like, it's, you know, I mean, it's like 2006 or 1006. It's whatever way,
Yeah.
but if it's fast for you, then yeah. Same with that unit circle thing.
Yeah, it's just a weird way of doing it.
Yeah, I think the way I did it was better. No, because you have to memorize. Like, okay, let's move on though. So this is the one, right? The y-intercept one.
Wait,
Okay. Okay, I think, yeah, we're good on time. So what about it first? What's something that's blurry?
Oh, okay, so like, okay, for like number 5.
Okay.
I don't think I printed that one. I think I printed one where it's like the zeros of y equals 2 cosine 1/2 x, and the interval is 0 to pi.
So this is not the one you're talking about?
No, but can you go over that?
Yeah. Wait, first of all, do you get these ones?
Um,
The y-intercept. Y-intercept is just anything, right? Like, and the line. What does a y-intercept mean? That's x equals 0, right?
yeah.
Yeah. So like, just to summarize it, plug in x equals 0 and then solve for y, which should be your y-intercept in all of these. Right?
Yeah.
Okay. And that one's just evaluating you've done that already, evaluating the trig functions at a certain x. So
yeah, like secant would be the same as like cosine, right?
The which one?
For the y-intercept, secant would be the same as cosine, and like cosecant as sine, right?
Yeah. For
okay.
this one, some of these are a little bit weird. What is this number 2? Can you?
Is
like,
it 1?
So maybe I'll cover it. Okay. So
Okay.
when you're doing like cotangent of
Oh wait. Sorry, I thought that said. I don't know why. I thought you were talking about number 3. Okay. My bad. Okay.
Okay. So what is cotangent?
It wouldn't have one, would it?
It wouldn't have one. Yeah. So the y-intercept equals does not exist, undefined. So even if it's like sometimes you just have to like some of these will not have one because obviously, right, you're switching to 0, right?
Yeah.
Like, yeah, exactly. Same with this guy, right? I think it'll be 1 sine of 0.
Yeah.
Yeah. So okay, just be aware that that happens. It's just one of those like you gotta accept it. It happens. Okay, whatever. Move on. So 5. So for this one, like they give you for most of these, they give you like an interval, right?
Mm-hmm.
Do you understand this notation by the way when I do this?
Yeah.
Okay, I don't like the way people usually do these. So it's like, I mean, it's math, but there's like a different way of doing it.
Mm-hmm.
So it's just an element. It's just a range of negative 2 pi to 2 pi.
Mm-hmm.
So what you have to pick out values here that will make, these. It's solving for x in a sense, right?
Mm-hmm.
And like I do, this is 2 questions, so I would answer them one by one. So for this one, every time you have like this counterpart of like
Mm-hmm.
one of the drag functions, the reciprocal version, I would just write its reciprocal and then solve for, do the cross multiplication, right? You just do that, right? It's the same thing. So this right here is exactly the same as what I just did.
Mm-hmm.
And then you solve this one, which is easy than like doing a secant. Like, I have no graphs of like what secant looks like or cosecant, but that's why I always, every time I see secants and cosecants and cotangents for that matter, I always transform them to their counterparts. So anyways, cosine of x equals 1. I mean, can you guys use your calculator by chance? No, right? Or no?
No.
Okay, because then it will be just, arctan or inverse cosine of 1. Anyways, if you can't do that, then you have to pick out values, just plug and chug. Or you could technically just graph it, right?
Mm-hmm.
You could technically just graph like the graph of cosine, which is, this is just asking where is it 1, right?
Yeah. So.
It'll be at 0
Mm-hmm.
and like 2 pi, I think. I'll do this thing. So 0 and 2 pi and then negative 2 pi, obviously. It'll be 0 and 2 pi and negative 2 pi. So it's going to be for the first one, it's going to be x equals 0, or start with the negative. Oh, are you kidding me? Oh, no. It does this sometimes. Hold up. Okay, there you go. So x equals negative 2 pi, 0, and then 2 pi. For the first one. And then for the second one, does that make sense?
Yes.
Okay. For the second one, it's wanting you to do if it's negative 1, which is just the other one. So this one is just the bottom one. You just look at the bottom, which is like right here. This is at pi, right? For like 0 to 2 pi.
Yeah.
So it's the counterpart is also true. So it's going to be x negative pi and then pi is when secant x equals negative 1.
Okay. Okay. Yeah. Okay.
So yeah, the trick to those ones is just transforming it to its counterpart and doing the cross multiplication.
Mm-hmm.
Nothing too bad, nothing too hard. Like it's just really they're wanting to know if you really know your trig reciprocal identity, and then like the best way is just graph it and then pick out the values that matter.
Mm-hmm.
Does what about these other ones? So do you know how to do them now? Like kind of like covering. Okay, good. Okay, we can take a look at these again. But what about? I guess in terms of like questions, and then like I'll cover the ones like I'll cover them thoroughly tomorrow. If we and then in terms of other questions, what did you have? I'll cover the rest of them tomorrow though, like thoroughly, like how I did it here.
Yeah.
Did you do this on the mixed review one?
I don't think so.
Okay.
No, I don't think I got that one.
Okay, I think this was a Word document somehow. I think
Oh.
I forget if I sent this one to you. We'll cover it though. I think it'll be helpful because besides like the actual graphing, there's some conceptual stuff in here.
Mm.
And then I think this is true or false.
Yeah, I can try doing that before our meeting tomorrow.
Okay.
What time are the meetings?
Oh yeah, same time I believe. I think it's the same time because you said that
Okay.
this time works, right?
Yeah.
Okay. Yeah, I think I wanted to do this so that if you had lingering questions, and then obviously doing some speed drills.
Yeah. Okay.
Okay.
Maybe I can read it really quick. Okay.
It's kind of weird because I think this is actually the same thing.
Yeah, it's just always.
No, I was looking at this. Like, is this the same thing?
Okay, what the heck is number what the heck is sinus?
Sinusoidal.
Yeah,
Sinusoidal.
that.
Yeah. No, the word itself is like the full formal terminology of sine. It's not sin. It's
What?
sinusoidal.
What?
Cosidal,
What?
sinusoidal, and then
That. Ew.
yeah, I know, right? Sinusoidal. It sounds like something. I know.
Yeah.
But no one ever says that. So it's just cosine and sine.
Like it means it has a midline of y equals 5. What is that? What does it mean by midline?
Okay, sinusoidal has that. Let me just read this. That has a midline of
Okay.
y equals 5 and an amplitude of 3. And completes 4 cycles in an interval of could have an equation. Oh, midline. Midline is like the this thing right here. That's the midline.
Oh, okay.
Yeah. So, yeah, that's I would say it's probably because this is plus 5, so 1. Yeah, just try to do this one. I'll send this to you. So let me see, 4, 6, 5 would be the midline. Yeah.
Mm-hmm.
Just looking at this, and I'm not trying to do the whole thing. So the midline could work, and the amplitude of 3. It is 3, but it's -3 though.
Mm-hmm.
So yeah, these ones will get difficult because then like you really have to break down the words, and then see if the result they give you. That's why it's good at the same time because does your teacher usually give you guys conceptual stuff or mostly just computational?
Mostly just like plain graphing.
No, like for like the first exam. You guys already had the first exam, right?
Oh, there was some, yeah.
Like true or false?
Yeah.
Also, they do show up. Okay. But also, like the way if I were to give an exam in like trig or like precalculus, usually the ones I've had were just graphing, like computational.
Mm-hmm.
True, like conceptual stuff is really meant for not a math class.
Yeah.
But I guess it's fair. Yeah, we'll go over these. Try to like see if do you have this one as well?
Yes, I have that one.
Okay. What about this guy?
I think I might. Wait. Yeah, I do have that.
Okay, so this is the only one you don't have?
Yes.
Okay. And I didn't actually show you this other one. I don't know if we should. It says packet on this. Do you know what this is?
Oh, that's the packet.
This is the one that you have.
Yeah.
Oh, so you did this all of these already?
Yeah.
So this is the packet that she's talking about. Okay. These, like, I was a little confused about in the beginning here. Like, are you supposed to just graph this guy?
Yeah, you graph it.
But it's easy though.
Yeah, that's notes. It was like the very beginning of what we did.
Yeah, and I was like, this is not testing you anything.
No, that was like the notes.
That makes sense, yeah. No, that's why I was like, I wanted to start with the beginning of all this. It's like, we're gonna skip this. This is not something in the test.
Too beginning.
Way beginning. And what
Yeah.
is R? What is this R?
Range.
Okay. So for the one, like, I have that question for you guys. Like, would you just define it, or is it just something that, like, where does she want you guys to graph it? From what range to what? 0 to 2 pi?
Like,
or negative?
Yeah, or depending on the pi. Like for cosine, the range would be like -1, 1, like that type of thing.
Okay.
So it's just like so cosine, we normally do it over 2 pi, and like
Okay.
everything else by kind of or
Okay.
just a tangent, but that doesn't really change for range.
Yeah, it shouldn't. Yeah.
Yeah.
Okay. Okay, so I think yeah. So we're with that. We'll probably cover. There's one more I wanted to cover to like Tuesday maybe, but
Mm-hmm.
like the ones that you have, that your teacher has, they're good problems, but there's some challenging ones. I don't know if does she usually transition the problems from her practice, or is it usually harder than the practice?
Um, they're
Like, because
normally
you've already seen the first exam. That's why I wanted to gauge, like, if
yeah
we
they're
should
they're,
go.
they're kind of like equal,
Oh,
really.
they're equal. Okay, that's
Kind of.
fair.
They tend to be like a little more hard ones on the practice.
Yeah, because I do have harder ones. Like I've looked at the ones that we just graph in Quiz E. There's some hard ones that we can go over, like these ones.
Oh my lord. Okay.
Yeah,
Uh.
there's actually harder ones than this. Like when they actually stacks
Uh.
it. You have like
Uh.
all four.
I
If
don't
you
think
had
we've
all
even
four
learned
of
that.
them,
We haven't even learned that yet.
yeah, it's if you can like my mantra is usually if you can do something harder, you can definitely do something easy.
Yeah. That makes sense, I guess.
Yeah, and there's like other people don't really complain, but yeah, we'll definitely go over these, and then if we have time, we'll go over the harder ones.
Okay.
Cool. I think yeah, I'll let you go early because that you didn't have that much questions unless you have one more.
No, I don't. No, I don't think so. I get what we're learning so far, and you explained like what I was confused about.
Oh, perfect. Okay. Yeah, I'm really hoping that you get an A, on this
Yeah, me
class.
too. I'm
It
like,
seems
what?
like it's always like that. Like, oh, I feel confident. I think I'm doing pretty well, and then the exam comes.
Yeah, and it's like deer in headlights. It's like, oh my gosh.
Yeah, don't let me down.
I will. I will. I'll try not to. I promise.
Okay, cool. Have a good one.
Okay. Thank you.
All right, see ya.